Good evening, children. Welcome to Akshara IT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Okay. So today topic is problems based on the surds. Okay. And our previous class we have discussed about what is surd and types of surds based on the order and based on the terms also. Okay. And how to convert the mixed surd or simplest form to entire form and entire form to simplest form. Okay. Now let us see the laws of surds. Let us see the laws of surds. Okay. Now the first law is nth root A into nth root B. While you are observing these two, nth root A and nth root B both are similar surds, right? Nth root A and nth root B both are similar surds. Am I right? Okay, its order is same. Am I right? Yeah. Both of them is order is same, and according to the definition, we know that n must be the positive integer and a can be the rational numbers. And between them, when you have the into symbol, so we can directly multiply their radicands. So nth root A into B. Nth root A into B. Same way, nth root A by nth root B equals to nth root A by B. Same like laws of exponents. A power m by B power m is nothing but A by B whole power m. Okay. So what are similar surds? Similar surds are nothing but the radicands must be same. The radicands must be same. Order must be same and the radicand also must be same. Then we can call the similar surds. Okay. Next, third property, third law of surds is nth root A. Nth root A is equals to mnth root A. Mth root A equals to mnth root A. This is the third law of surds. Okay. Yeah. So mainly these three are sufficient for solving a problem. What are the uses of laws? We can convert the pure surd into mixed surd and mixed surd into pure surd. Okay. Na? For that we can use the laws of surds. Excuse me. Okay. Now let us see the problems based on the surds. Okay. So you have to remember these three, the laws of exponents mainly. So separately if it is given, we can multiply the radicands directly when the order is same. Nth root A, nth root B. Both are having the same order. Okay, na? Now here also both are having the same order. We can write nth root A by B. This is only happens between into symbol and division symbol. But we cannot write nth root A plus nth root B is nth root of A plus B. It is not equals to nth root of A plus B. Both are same. Whenever between into symbol and division symbol only, we are able to apply the laws of surds like this. Okay? Yeah. Let us see some problems based on the surds. Which of the following is a surd? Okay, let us see some examples and identify the which of the following are surds. That is fourth root 81. Second one is cube root 27 and third one square root 16 and the fourth one root over 8. All are having root form only. All are surds only. Yeah? That's why I told you whenever nth root A is a positive number, or n is a positive integer and A is a rational number, when only, then we can say that it is a surd when A should not be in the power of, A should not express in the power of n. Okay, na? For example, first option if you observe that, 81 we can write as, let us try to find out the prime factors here, 81 we can write as, so 3 27s are 81. Next 3 9s 3 3s and 3 1s. So we can write 81 as 3 power 4. We can write 81 as 3 power 4. And I told you already, nth root a is nothing but a power 1 by n. Same way if you convert like this, 3 power 4 whole power 1 by 4. By using the laws of exponent, a power m whole power n is nothing but a power m into n. Then 4 4 cancel, 3 power 1 means 3. 3 is a rational number. Why? Because its order is 4. 81 also expressing as power of 4. So it is a rational number. Same way 21 also can be expressed as power of 3. 3 cube value 27. 3 into 3 into 3 is 27. So it is also a rational number. Now 16 its order is 2. Square root order is 2 and 16 can be expressed as 4 square. 4 square value 16, order is 2, here 4 is square number. That means 16 is a square number. So this is also a rational number. First 3 are rational numbers. Let us check 8. 8 is not a square number, but it is square root. Order 2, but 8 is not a square number. So option is root 8. Okay, now? Let us go to the question number 2. The second question is, which of the following is not a surd? First option is cube root of 4. Can you express 4 as power of 3? Exponential form. Exponent must be 3. Square root 3. And third option, square root 8. And the fourth option is cube root 27. Cube root 27. Now check here. 4 cannot be expressed as powers of 3. Cannot be expressed as powers of 3. And 3 also cannot be expressed. 3 is not a square number. 8 is also not a square number. 27 is a cube number. Order 3 as well as 27 is a cube number. So this is a rational number. Remaining all irrational numbers. First 3 options are irrationals. Okay, na? Let us go to the question number 3. That is given the order of the surd of square root. What is the order here? In the root, not that anything is. We are reading it is square root. That means root over 7 or square root of 7 both are same. So from this we can say that order is 2. Okay, na? I told you already in nth root A, n is called order. A is called radicand and nth root is radical sign. Nth root is radical sign. You can remember, right? Yeah, the order of square root is 2. Next, let us go to the question number 4. That is 2.7128 and so on. 2.7128 and so on is an example of, what is this? Decimal number, but its and so on is indicates the decimal values are continuing like that. And try to identify any terms are repeated. No. While we are discussing about the rational numbers decimal form is terminating decimal or non-terminating continued decimals or repeating decimals. But irrational numbers are non-terminating, non-repeating numbers. This dots shows that it is not terminating, it is continuing there. And can you identify any repeated number here in the decimal form? Not there anything. So there are different type of numbers. So it is an example of irrational numbers. Okay, now irrationals decimal form this one. Okay, right. Next, question number 5. The radicand of the surd cube root 3 into root 25. What is the radicand here? Yes, radicand is 25. Very good. Easy questions. Radicand is 25. Okay, now? Now, 6th question. An example of quadratic surd. What is quadratic surd? Quadratic surd is nothing but that order must be 2. Order of a surd must be 2 is called quadratic surd. Order of a surd is 3. cubic surd, order of a surd is 4, biquadratic surd. So surd example by quadratic surd example, while you are observing that must be square root. That is root over 12 is the example for quadratic surd because its order is 2. And remaining options, one is order 3, order 4, last one is compound surd. Okay. Next, let us go to the next question. The problem number 7 is, which of the following is a mixed surd? What is mixed surd? A rational number with surd is called mixed surd. That can be in the form of 3 into cube root 5 or 3 plus cube root 5, anything is same. This is both are in mixed surds only. Okay, na? Rational number with surd. So according to our option, so all are the, only the fourth option 2 into cube root 2 is our mixed surd. What are the options are given actually? Cube root 6. Second one is 4th root 16. And option 3, 4th root 8. And the last option is 2 into cube root 2. Okay. First one, pure surd. It's before, that means cube root 6 before there is no presence of number, that means only 1 will be there. So it is a pure surd. Second one is rational number because 16 can be expressed as 2 power 4. Okay, na? Same way, 4th root 8 is surd, pure surd, but last one 2 into cube root 2 is only the mixed surd. Okay, na? Let us go to the next question. The simplest form of cube root of 162. Asking about the simplest form of cube root of 162. How to find the simplest form of this number? First of all we need to find the prime factors of 162. Let us try here. 162 prime factors. 2 table 81 times. 3 table 27, 3 table 9, 3 table 3 and 3 table 1. So this 162 we can write as cube root of 2 into after 4 threes. But whenever the order is 3, from the same numbers 3 times will come without the root. That means 3 into cube root of remaining 2 numbers 2 and 3. 2 and 3 are presenting one time only. If 3 times, we can take it out. Okay, that is equals to 3 into cube root of 2 3s are 6. So root over 162. Cube root of 162 is 3 into cube root 6 is the simplest form. Okay, na? Or mixed form, whatever. Next question number 9. So let us see the question number 9 here. That is the value of 4th root 1296. 4th root of 1296. Let us find its simplest form also by finding the prime factors. Okay, na? So 1296. Now 2 table again. 2 6s are 12. 2 4s, 2 8s. Again 2 3s are 2 2s are 2 4s are. Again 2 table 16, 162 times. Again same continue. 162 onwards same numbers continue. That means 2 table 81 times. 3 table 27. 3 table 9 times. 3 table 3 times and 3 table 1 time. So while you are observing that 2 is presenting 4 times, 3 is presenting 4 times. So we can write this one 2 power 4 into 3 power 4. Am I right? 2 power 4 into 3 power 4. While you are writing this 2 into 3 whole power 4 by using the formula a power m into b power m. A into b whole power m. And 4th root means whole to the power of 1 by 4. So numerator 4, denominator 4 cancel. 2 3s are 6. This is the 6 power 4. 6 power 4 value, this one. So we can cut square root or fourth root and 6 power 4. Okay. This is the simplest form. Next. Again, simplest form of 50 by 4. Simplest form of 50 by 4. Okay, na? That's the question. Root over 50 by 4. Now try to cancel both of them. Try to cancel both of them in 2 table. 2 25s are 50, 2 2s are 4. And while you are observing here, 25 is a square number. 25 is a square number. So 25 we can write as 5 into 5. But 2 is not a square number, it is prime number. 2 as it is 2. Okay, I am separating the square root. Root over 5 into 5 by root over 2. So previously we expressed that nth root m by nth root a is equal to, nth root a by nth root b is equal to nth root of a by b. Same like that we can separate it. So from these 2 5s, 1 5 will come without the root and remaining is root 2. So 5 by root 2 is simplest form of root over 50 by 4. Okay, now check. Next one. The product of two similar quadratic surds. So when you multiply any two similar quadratic surds, that will be the rational number. The surd becomes a rational number. Two same surds, product of two same surds, that must be the quadratic surd. That will be a rational number. Let us see this. Question number 11. Product of two similar surds. That two not only similar surds, product of two similar quadratic surds. Quadratic surd means order 2. Quadratic surd means order 2. For example, if you are taking square root of 3 into square root of 3, okay, no? Or 2 into square root of 3 also is similar. Whenever it is having the same radicand with same order of surd, we can say that these two surds are similar surds. Root 3 is similar to itself, 2 root 3, 3 root 3, 4 root 3, these are all the similar terms of root 3 only. Okay, na? For example, I am taking 3 root 3. When you multiply both of them, 1 into 3, 3, root 3 into root 3, we can write like this. 3 3s are 9, or 3 into 3 we can write as 3 square. 3 square means only 1 3 will come without the root. So 3 into 3, 9. So 9 is a rational number. So whenever if you take any two similar quadratic surds, their product is rationals. Their product is rational number. Okay, na? And product of two dissimilar surds. 12th question. Product of two dissimilar surds. Product of two dissimilar surds. For example, cube root 5 into cube root 7. Cube root 5 into cube root 7. That will be cube root of 5 into 7. 35. So we cannot simplify. We cannot simplify more than that. It is again a surd. So product of two dissimilar surds is a surd, but product of two similar quadratic surds is a rational number. 12th one answer is surd. Check. Okay, na? So let us go to the question number 13. That is fourth root of cube root of 3 power 6. Fourth root of cube root of 3 power 6. So we can apply the formula, that is mth root of nth root of a power n or a power p something. We can write mnth root of a power p. Okay, na? Same way 4 into 3, 12. So 12th root of 3 power 6. Again expressed in simplest form. That means 3 power 6. 12th root means whole to the power of 1 by 12. 12th root means whole to the power of 1 by 12. That is equals to 3 power 6 into 1 by 12 by using a power n whole power n formula, a power m into n. 6 table in 12 2 times. 3 power 1 by 2 nothing but square root of 3. 3 power 1 by 2 is nothing but square root of 3. Okay, na? Check. Coming to the next question, that is, next question is, if a, b, c are rational numbers, then we need to find that a plus b root 2 plus c into fourth root 2 equals to 0. Okay, na? So from this case you should understand, whenever you are adding different surds, these are similar surds, not these are dissimilar surds, not similar surds, unlike surds. Unlike surds, because radicands are same but order is different, no? So we can make them into, convert them. We can convert them into similar surds, but right now they are dissimilar. While you are adding the dissimilars, you are getting 0. We cannot add or subtract the dissimilar surds. So, but here answer is 0 means all of them, a value, b value, c value, all must be 0. Then only it will happen. Okay, na? Next, exercise 1. Observe the first question. Surd of order 4 is called biquadratic surd. Surd of order 4 is biquadratic surd. Okay, na? Third, 3 into 4th root 5. 3 into 4th root 5 is a pure radical sign. As pure radical sign. So we need to convert them into pure surd. Pure surd means before 3 is there, but whenever in the place of 3 if you have 1, then only we are calling pure surd. So this 3 I should take into inside. That means it is already 4 order 4. 4th root, no? So whenever you are take this 3 to inside, it will be 3 power 4. It will be 3 power 4. That means 4th root of 5 into 3 power 4 value 81. 3 power 4 value 81. 3 into 3 into 3 like that 4 times. That means 4th root of 405. This is the answer. Okay, na? This is the pure surd. Okay. Now question number 3. That is given that the question number 3 is fourth root of 3 into 4th root of 2. Yeah. So it is looking like a formula of mth root a into mth root b, nothing but mth root ab. Same order we can directly multiply like this. Same way the answer will be 4th root of 3 into 2, that equals to 6. 4th root of 6 is our required answer. Okay, na? Yeah, please note that. Next, entire form of 2. Entire form or pure surd form also same. Entire form of 2 into cube root 5. 2 into cube root 5. So, what is the order of this surd? Order is 3, because here 3 is there. Now for cube root of 5, when you take the 2 inside the cube root, it will be 2 cube. Okay, no? 2 cube means 2 into 2 into 2, that means 8. So cube root of 40. 5 8s are 40. Note that, please note that. Let us go to the question number 5. That is k plus 1 into 4th root of 5 is entire form. 4th root of 5 is an entire form. When you will get that entire form here? Entire form is entire form or pure form. Fourth question, see, entire form. Entire form is we have to take this k plus 1 to inside. But here, if it is already in that entire form, we need to find the value of k. Entire form means the surd must contain the previous one, quotient or nothing, but it must be 1. That means k plus 1 value must be 1. Then k value is 0. Then only it will be, it can be the entire form. That's simple, entire form of a number. Please note that. Next, question number 6. The question number 6 is given the pure surd form of 2 by 3 into root 32. Pure surd form. Okay, no? That means 2 by 3 should be 1. For that, we have to take that 2 by 3 inside the square root. Square root means order 2. That means it will be 2 by 3 whole square. That is equals to square root of 32 into 2 into 2, 4, and 3 into 3, 9. So multiply here, that is 2 4s 8, 128 by 9. This is the pure form. Pure form of a surd. Okay, now? Yeah, that's it for today, children. Thank you one and all. Have a nice day. Bye bye.